Welcome to this video from Derby Physics Tuition, and I've been working with the students studying GCSE physics, and we've been looking at the physics of falling, and namely how an object reaches terminal velocity when a parachute is opened. And we're going to look at the physics involved by examining a past paper question, and let's get straight to it. This is the question, and it's about the spacecraft Schiaparelli that was sent to Mars in 2016, and Schiaparelli slowed down as it fell vertically through the atmosphere of Mars. Draw labelled arrows on the diagram to show the forces acting on Schiaparelli as it fell. Okay, now notice here there are 3 marks for this question, so we'll just put a dot in the center of the spacecraft, and it says that the spacecraft slowed down as it fell. So we've got the weight of the craft, and we'll label that W. Now if the spacecraft is slowing down, if it's decelerating, then there must be a resultant force acting upwards. So we've got the force due to air resistance, and or due to the resistance of the atmosphere on Mars, and that must be greater. So we'll label that force D, and that force must be greater compared to the weight. So there must be a resultant force upwards which is causing the spacecraft to slow down. So we'll label those 2 forces, drag and the weight. So just to clarify, where do those 3 marks come from? Well, first of all, it says draw labelled arrows. So you have to first of all draw an arrow labelled weight. That would give you 1 mark, and then you have to draw an upwards arrow labelled drag. That would give you the 2nd mark, and showing that the drag is greater than the weight would give you the 3rd mark. And so that's where the 3 marks come from. And the next part of the question is an aspect of physics that students find difficult to explain coherently. So we're going to go through it step by step, and part 2 of this question says Schiaparelli then opened a parachute to slow down. Explain how the spacecraft reached a low terminal velocity after opening its parachute, and use ideas about forces in your answer. So the first thing that happens when the parachute opens is that the air resistance increases greatly when the parachute is opened, and the air resistance will be greater than the weight. So if we draw that as a free body diagram, there's a dot to model our space probe. The air resistance, or the drag, is much greater than the weight. And so now what we could say is that we have a resultant force acting upwards, and the spacecraft will decelerate quickly, so its speed will quite rapidly decrease because the resultant force is acting upwards. Now if it slows down, then the air resistance will also decrease, the drag force will also decrease because the spacecraft is slowing down. And so what happens then is that the resultant force will become 0. So if we draw another free body diagram to represent that, the weight doesn't change, but because the spacecraft is slowing down, the drag force will decrease, and you will get a situation where the drag force and the weight will become equal, and that will mean there is no resultant force. The 2 forces cancel each other, there's no resultant force, and you end up with the fact that the space probe will achieve or reach a smaller constant speed, or a smaller terminal velocity. So quite a lot involved there to explain that properly, and it's always best answering these type of terminal velocity questions by adding diagrams in as well, just as I have done, just so that the examiner can see exactly what your thinking is. And hopefully you found that useful, and if you do have any questions or comments, please do leave them in the comments section below, and thank you very much.